This video will be about section 2.3 in a Triola textbook for statistics. Talk about graphs and then interpreting them and various different types of graphs. So the visual display of quantitative information offers these principles to follow. For small data sets, 20 values or fewer, use a table instead of a graph. A graph of data should make us focus on the true nature of the data, not other elements such as eye-catching but distracting design features. Do not distort the data. Construct a graph to reveal the true nature of the data. Almost all of the ink in the graph should be used for the data, not other design elements. So let's look at our first one here, a dot plot graph. It consists of a graph of quantitative data in which each data value is plotted as a point or a dot above a horizontal scale of values. Dots of equal value are stacked. So for example, here I have 40 and I have a dot above it. So that's 40. Then 41, there's a dot above it. Look at 50. There's two dots above it. So there are two 50s. 51 has 1, 2, 3, 4, 5. So in essence, you see how many of each data point you have, and then you kind of get an idea of the bar, of a bar graph. So this shows a dot plot of pulse rates in beats per minute of males from dataset 1 of the body dataset in Appendix B. The two stacked dots above the position at 50 indicate two pulse rates that are 50. Another type of graph is a stem plot, or stem leaf graph. It represents quantitative data again by separating each value into two parts. You have the stem, which is the leftmost digit, and then you have the leaf, which is the rightmost. So in this example here, 40 would be the 4 would be the part of the tens, and then the 0 is the ones, and 42. So we have pulse rates 40 and 42. Going back up here, you'd see them here, 40 and 40. I guess this was an even number 2, so 40 and 42. 50, 50, and then you have 52, 52, 52, 52. So you get to see them, but now this is on a kind of horizontal graph. But you're able to see how many there are and kind of how many of each specific ones there are as well. A time series graph is data which are quantitative again. They have been collected at different points in time. So you'll notice they're dots, but they're also connected by a solid or dashed line. So here is the first one, May 22nd. Here's the second one, May 23rd. And then we connect it with a line. So you can create something close to this in statcrunch by going to Graph, Chart, and Column. And then you select the Y value for your data, and your row labels are selected in the column. And you change the plot to points with connected lines. So that's if you want to create something in statcrunch, and we'll do that right now. Go to statcrunch. I have the years over here in the first column, and I have the births, how many births there were in that year. Let's create a connected dot plot graph. I go to Graph, I go to Chart, and we're in columns. So the births will be the numbers, and the rows or the labels are the years. That's what I want labeled. We'll go order by worksheet is fine. We'll plot. We don't want to plot horizontal bars. We want to plot points with connected lines. And then we compute. And then here I get the connected dot plot, and it shows me row 1, births 1910, 27, and we have it matching up, right? 1915, 2965. So it matches up. So now you can visually see when it was low, maybe something was going on around this time, right? And when it was high. Another option is a bar graph. We've looked at that. It uses bars of equal width to show the frequencies of categories of categorical data or qualitative data. Bars may or not be separated by small gaps. We ought to be able to see that we have the labels down here and then the frequency tallies going up, right? Okay, a Pareto chart. That's something a little different. It's a bar graph again for categorical data with the added stipulation that all the bars, I should say bars, are arranged in descending order. So we're only kind of interested in the top values because this was some kind of medication, types of medication errors, right? And there's a little bit more to this chart. You see they have this 80% cutoff rule, 80-20, and they have this kind of line here. They call this the trivial many. But they're really interested in these 92 problems, what the dose was missed. So we go for the most, and then it goes down to the least. So these ones aren't as important. They're not going to worry so much about these. They're going to work on these values here, the vital few, they call it. So it's ordering from highest to lowest, left to right. A pie chart. So a very common graph that depicts categorical data as slices of a circle in which the size of each slice is proportional to the frequency counted for that category. So it says although pie charts are very common, they are not as effective as Pareto charts. So if you're making decisions, you want to have that Pareto chart. Versus the pie chart, it's commonly, you can see this, but remember, you need to have something where you have a whole, like all the grades in the class. How many students got an A, B, C, D, F, right? Then you add them all up and they have to equal 100%. The one major benefit of a pie chart is that it immediately sells the idea of the part to whole comparison. So with a bar chart, it may not be immediately clear how much the bar chart contributes to the whole. So a lot of times that's when we want to show kind of the difference in sizes of how this piece compares to the other pieces in the pie. So that's when you'd want to use a pie chart. Pictographs. Here's something that looks basically very simple, but it can be deceiving and you got to be careful. So favorite pets of grade 8 students, this would be a English version like British, Great Britain. So they have cats, dogs, and fish. And if you just looked at it just right away, and you didn't read this down below, right? You just kind of scanned it, you would automatically think maybe that there's more fish than there are cats or dogs for their favorite pets. They like fish more. But if you, because you might be thinking length, right? But it's actually, they represent the same, 10, 10, 10. So actually, there are 40 dogs, 40 cats, and 30 fish. So actually, the dogs and cats are the same. So you have to be a little careful when they're drawing like designs to kind of show you information and in these pictographs. Okay, the last thing we're going to look at is a frequency polygon, and we'll go do that in statcrunch again. We'll go back to our McDonald's example. Here we have our classes and our frequencies. Let's take a look at that data in a frequency polygram, which uses line segments connected to points located directly above the midpoint values. So now you're going to be looking at the midpoints of these classes. So I look at 75 plus 124 and divide by 2. I get 99 as the midpoint. I get 149 as the midpoint, 0.5 as the midpoint. Now I can sit there and calculate them all out all the way down to 299.5, but the class width, as we remember from previously, from 75 to 125 is 50. So we could just keep adding 50 onto this until we get to 299.5. We don't actually have to do the calculations. Once we find the first one, just add 50, add 50, add 50, add 50, all the way to the end. And that will give us our midpoints. Now you look on my chart here, I have those right here, those midpoints of the data. But then I have also two other points. And that's because we also need to have anchor points on the polygon frequency, or frequency polygon, excuse me. The anchor points anchor the graph to 0. And so I add these two in here, and again, they're 50 parts below and 50 parts above the midpoints of those classes. So just subtract 50 and add 50 and make a new value with 0. That way, when we put it in our graph, we anchor them. And we're going to use the same method for the connected lines. We're just going to copy this information now, which is the midpoints, and then the values with the frequencies and the 2 zeros, and just go into statcrunch and make that chart. Okay, so now let's go to statcrunch. I've got this here table here, so I'm going to see if I can copy this, and I'm going to see if I can paste it into statcrunch. There I've pasted it into statcrunch. I've got my 49.5 to 0 all the way down to there. Now we're going to go in the graph, chart, columns, just like we did before for the other one, because we're going to create one of those connected lines. Now we see that our frequencies are over here. That's the data, so variable 3. Not sure why the names are off, but and then variable 5 will be the rows, because that's where the labels are on the bottom. So always we select the one with the frequencies in it. We change the plot to points connected with lines, and then we click compute. And then we see our polygon, frequency polygon, and these are the midpoints. We have it anchored at 0 and 0, and then we have the midpoints of each of the classes and then their frequencies for that class. What this allows us to do is to see the distribution, to see if we have a normal distribution or if we have another way of looking at it versus just the frequencies. One of the main advantages of a frequency polygon is that compared with a histogram is that you can superimpose 2 or more frequency polygons on the same axes and make comparisons between the data. So I could put another one on here and you'd be able to see it, versus having bar graphs, you can't lay them or superimpose them over top of each other and see the data. So this is a good way to compare different sets of data. So I have the data in here in a YouTube video if you'd like to see it again. Otherwise, that's all there is in section 2.3. Now remember, these are kind of like the cliff notes of 2.3. Please check the book and put questions in discussion.